We're going to look at an application question of parallel and perpendicular lines. So it says show that the quadrilateral ABCD given by the vertices is a parallelogram. Well, if it's a parallelogram, it must have two pairs of parallel lines. And we've learned how to find the slope of lines. And if they are parallel, then they have the same slope. So if we're looking at the slope of AB, and we use, of course, the slope formula, y2 subtract y1 over x2 subtract x1. We see that we can get the slope of AB as a half. The slope of CD is also a half. The slope of AD is -8, and the slope of BC is -8. So we have BC is parallel to AD because the slopes are equal. And CD is parallel to AB because their slopes are equal. So since there are opposite sides that are parallel, then ABC is a parallelogram. You can pause this clip if you wish and try the next question. I'm going to continue with it, and then you can play when you're finished working on it yourself. Here's C is 6 and 4. 1, 2, 3, 4. Here's C. A is 4 and -1. T is -3 and -2. And S is -1 and 3. The figure certainly looks like a parallelogram, but we do have to find the slopes of each side just to make sure. So we have the slope of CS, which is, I'm going to call C x1, y1. And this one's going to be x2, y2. And that'll be 3 subtract 4 over -1 subtract 6, which is -1 over 7, -7, and it is a positive slope of 1/7. I'll look at then the slope of CA. Since I already have C labeled x1, y1, I'll label A x2, y2. And that will give us -1 subtract 4 over 4 subtract 6. This gives us -5 over -2, which is 5 halves. Now we know CS and CA are not parallel. We'll look at now the slope of AT. And since A is already labeled x2, y2, I'll label T x1, y1. And that will give us -1 subtract -2 over 4 subtract -3. And this gives us 1 over 7. So I have one pair of parallel lines. And then we'll do finally the slope of ST. And we have S is x2, y2, and y is, x2, y2 for S, and x1, y1 for T. And so that will give us 3 subtract -2 over -1 subtract -3, which gives us 5 over 2. So we do have that CS is parallel to AT, and we have CA is parallel to ST, which tells us that we do have the opposite sides of this quadrilateral are parallel, and it defines a parallelogram.